July 19th, 2024, 8:47 a.m. Eastern Time. In the span of 60 minutes, 8.4 million Windows computers across the globe just stopped working. Delta Airlines grounded every flight. Hospitals in Europe reverted to paper records, banks froze transactions. 911 systems went offline. This wasn't a sophisticated cyber attack. This wasn't a nation-state hacking campaign. This wasn't ransomware. This was an update. One company, one configuration file, one critical mistake, and the entire digital infrastructure of modern civilization held its breath. I'm Tony. I've spent 2 decades working in cybersecurity and telecommunications infrastructure. I've seen systems fail, but I've never seen anything fail this fast, this globally, or this completely. Welcome to the Breakdown Economy, where we forensically examine why things fail so you can see the next one coming before it hits you. Today, how CrowdStrike's 20-year reputation collapsed in 20 minutes, and why this exact failure will happen again. All right, let's set the stage. Because to understand how spectacular this failure was, you need to understand what CrowdStrike was before July 19th. CrowdStrike wasn't some scrappy startup. They were founded in 2011 by George Kurtz, former McAfee CTO, and they became the gold standard in endpoint detection and response. By 2024, they were protecting 29,000 enterprise customers, half the Fortune 500 critical infrastructure, airlines, hospitals, financial institutions, government agencies. Their valuation? $83 billion before the crash. Their product, CrowdStrike Falcon, was everywhere. And for good reason. Now here's what makes this interesting from a technical perspective. Think of your computer's operating system like a building. Normal applications, your web browser, Word, Spotify, they run on the upper floors. User space, they have limited access. The kernel, that's the foundation, the electrical system, the load-bearing walls. Software running at kernel level has unrestricted access to everything. Memory, processors, drivers, the whole system. Falcon is an EDR solution, endpoint detection and response. It runs on your computer at what's called kernel level. Security software needs this access. To catch malware before it executes, you have to be deeper in the system than the malware itself. You need to see threats at the kernel level. But here's the trade-off nobody talks about. When you give software kernel level access, you're giving it the power to protect your entire system or destroy it. If it works, you're protected from ransomware, 0 days, advanced persistent threats, all the scary stuff. If it fails, your machine is a brick. And on July 19th, 2024, it failed. So what actually happened? Let's go step by step, because this is where it gets interesting. July 19th, 0409 UTC, that's just after midnight on the East Coast, CrowdStrike pushes what they call a rapid response content update. Now this is important. This wasn't a software update. This wasn't new code. This was a configuration file. Think of it like updating your antivirus definitions. You're not reinstalling the antivirus program, you're just giving it new information about what threats to look for. CrowdStrike does this constantly. Multiple times per day sometimes. It's routine. Automated. Low risk. Except this particular update, channel file 291, had a logic error. The configuration file contained malformed data, and when the Falcon sensor tried to read it, the C++ driver couldn't parse the content template data. In normal software, running in user space, this causes an error message. Application crashes. You restart it. Annoying, but not catastrophic. But remember, Falcon runs in kernel space. In kernel space, Windows doesn't have a safety net. There's no oops, let me catch that error. When kernel-level code fails, the operating system assumes something catastrophic has happened to the foundation of the system. So it does the only safe thing it can do. Complete shutdown. Blue screen of death. System crash. Boot loop. And because this was pushed to every CrowdStrike customer simultaneously, machines started crashing in waves across every time zone. Now here's the critical part, the part that transformed this from bad bug to global catastrophe. Let me explain to you how this should work. Here's the staged approach. Phase 1, internal testing, 100 machines. Phase 2, canary deployment, 1% of customers. Phase 3, monitor for 24 hours. Phase 4, expand to 5%, then 10%, then broader kill switch available at every stage. And here is the full deployment approach used that day. Push to 100% of customers simultaneously. No monitoring window, no kill switch, no rollback mechanism. Microsoft learned this lesson the hard way years ago. They now push updates gradually. 1% of machines. Then 5%. Monitor for issues. Automated telemetry watching for crash rates. If something goes wrong, you've affected thousands of machines, not millions, and you can pull the update before it spreads. CrowdStrike pushed channel file 291 to everyone, simultaneously. Within an hour, 8.4 million Windows machines crashed, 5,000 PAWS flights canceled, emergency services disrupted in multiple states, hospitals postponing surgeries, financial trading systems offline. And here's the worst part. The fix was simple. Delete one file, boot into safe mode, navigate to a specific directory, delete the bad configuration file, restart. But when you have 8.4 million affected machines, many in remote locations, many without IT staff on site, many that auto-boot into the crashed state, the fix took days, in some cases, weeks. Delta Airlines was still recovering a week later. Some hospitals were running on paper for 72 hours. The estimated global economic impact? $10 billion from one configuration file. Now, if this was just about CrowdStrike making one mistake, this would be a cautionary tale and nothing more. But it's not. Pattern number 1, speed over safety. The cybersecurity industry operates on threat velocity. New vulnerabilities discovered daily. Zero-day exploits in the wild. Ransomware variants evolving every week. CrowdStrike's competitive advantage was rapid response. Push updates faster than the competition. Detect threats sooner. The market rewards speed. Customers expect real-time protection. But speed and safety are inversely correlated. The faster you move, the less time you have for testing. The pressure to deploy immediately overrode basic deployment hygiene. And nobody pushes back because in cybersecurity, slow equals vulnerable. This is a pattern, and that pattern is accelerating across enterprise technology. Let me show you the 3 forces that made this inevitable. Pattern number 2, systemic concentration risk. Here's something that should terrify you. CrowdStrike, at the time of this incident, had kernel-level access to approximately 15% of all enterprise Windows endpoints globally. One vendor. One platform. Millions of critical systems. Graphic 8. Visualization of market concentration, pie chart or similar. This isn't unique to CrowdStrike. Look at cloud infrastructure, AWS outages taking down half the internet, CDN providers. Fastly incident in 2021 broke Reddit, Amazon, CNN, GitHub, simultaneously payment processors, Stripe downtime affecting thousands of e-commerce sites. We've created single points of failure at civilizational scale. And we did it because consolidation is efficient, economical, manageable, until it fails. And pattern number 3, the kernel-level testing gap. Here's the uncomfortable truth. You cannot fully test kernel-level software in non-production environments. The complexity is too high. The interaction between kernel drivers, different hardware configurations, various Windows versions, competing security software, the permutations are nearly infinite. You can test in labs, you can run simulations, you can have staging environments, but you cannot perfectly replicate production at scale, which means every deployment is to some degree an experiment. And we're running these experiments on air traffic control systems, hospital patient records, financial transaction processing, emergency services dispatch with kernel-level access and no staged rollout. What could possibly go wrong? This isn't hypothetical. We're seeing this pattern everywhere. Automotive, Tesla pushing over-the-air updates to vehicle control systems while people are driving medical devices, insulin pumps and pacemakers receiving wireless firmware updates. Smart home. IoT devices with cloud dependencies that brick when servers go down. AI deployment. Companies shipping large language models with minimal safety testing at scale. Same pattern. Different industries, all racing toward the same cliff. The only question is, who's next? Alright, so what do you actually do with this information? Because I'm not here to just tell you scary stories. I'm here to help you see breakdowns coming before they hit you. Here's what this means depending on who you are. If you're in IT leadership or system administration, this is your wake-up call to audit third-party kernel-level access. Ask yourself, what software has kernel-level access in your environment? What is their deployment methodology? Staged rollouts? Canary testing? Do you have rollback procedures if an update fails? Can you boot into safe mode remotely? What's your recovery time if every endpoint crashes simultaneously? And here's the hard question. Can you survive without this vendor for 72 hours? If the answer is no, you have concentrated too much risk in one solution. Start planning redundancy now. If you're choosing security vendors or enterprise software, change your evaluation criteria. Don't just ask what features do you have. Ask, how do you deploy updates? Show me the process. What's your rollback mechanism? Have you ever had a bad push? What happened? What changed? Do you use canary deployments? What's your blast radius if something goes wrong? And if they can't answer those questions clearly and confidently, walk away. Features don't matter if the vendor can brick your entire infrastructure. If you're an investor or business leader, companies with concentrated platform dependencies just became riskier. The CrowdStrike incident wiped $25 billion off their market cap in 2 weeks. But the bigger story is what it revealed about systemic brittleness. Start asking, what's our single point of failure? Where have we concentrated risk for efficiency? What's our exposure to platform dependency? Diversification isn't just for your stock portfolio anymore. It's for your infrastructure architecture. Look, CrowdStrike will survive this. They're too embedded in enterprise infrastructure. They'll pay the fines, settle the lawsuits, improve their processes. Their stock has already recovered most of its losses, but their reputation took a hit they will never fully recover from. Because now, every CIO in every board meeting has to answer the question, could we be the next CrowdStrike incident? And more importantly, this showed us the blueprint for how modern infrastructure fails. Not slowly, not with warning signs, not predictably, fast, globally, catastrophically, from a single configuration error. We built a civilization on digital infrastructure optimized for speed and efficiency. We connected everything. We automated everything. We centralized everything. And now we're discovering what happens when everything is one bad push away from collapse. The CrowdStrike incident wasn't a one-off. It was a preview. The question isn't if this happens again. The question is, will you see it coming? This is the Breakdown Economy. I'm Tony. Every week, we're going to forensically examine a failure. Why it happened, what pattern it reveals, and what it means for you. Because in a world where everything is connected, understanding how things break isn't optional anymore. It's survival. Subscribe if you want to see the next breakdown coming before everyone else does. And if you work in IT, cybersecurity, or infrastructure, I'll see you in the comments. Let's talk about what we're seeing out there.